Now, it is one of the most elusive prizes in particle physics, discovering the nature of the Big Bang, how we and our system were created. Scientists at the Large Hadron Collider near Geneva have announced they believe they have tantalizing hints of the Higgs boson, the so-called God particle. Well, the LHC, there you can see it, the Large Hadron Collider, is a giant ring measuring 27 kilometers in circumference. It's built underground beneath the Swiss-French border near Geneva. It takes subatomic particles known as hadrons, in this case protons, and smashes them into each other. This is done by accelerating them in opposite directions around that ring. Watch this. The collisions result in energy and a shower of smaller particles. There you can see it. It's always been thought that one might just be a Higgs boson, and that particle is thought to give atoms their mass. It's crucial to our understanding of the universe. Well, I'm joined by Martin Archer, a space physicist at Imperial College. Now, you understand all this. I'm trying to make it simple for people out there. Let's take ourselves through the science of this, can we, Martin? Particularly with the way the Higgs boson works.
Okay, so as you said, the Higgs boson is supposed to be all about mass. And actually,
what are we seeing here?
This is the so-called Higgs field. So this permeates the whole of space, and particles can travel through that. Now, this is a fairly light particle, so it didn't really feel the effects of the Higgs field so much. But as we go to progressively heavier particles, these would, without the Higgs field, be traveling at the speed of light. But you can see these Higgs bosons are interacting with these particles, slowing it down ever so much. And if we look at the next particle, when that comes along, that will be much heavier, and you can see the sense of mass, that resistance to motion, is given by this interaction by traveling through this Higgs field.
And what are all those things that look like tadpoles?
Well, those are supposedly Higgs bosons popping up and out of existence all the time, which is how this Higgs mechanism works, that gives every particle its mass.
Now, let's talk about the science of this and how they've been doing it in CERN with the technology. Here it is, Martin.
So we can see these are the protons. These
what are the protons here?
Well,
these things here?
Yes, those things
okay.
there. They're protons, and they fire them together at extremely high energies, touching energies very close to what were
through this tunnel. Yes, 27 kilometers.
Indeed, yes. Two beams going in opposite directions until they collide them, and they make a whole manner of different interactions, as we can see here. So
that's them colliding.
You get a weird interaction. You get lots of different particles coming off. Now, scientists can detect these particles, work out what they were, and track them back, and then try and work out exactly what the interaction was and whether a Higgs was present at some point in that detector.
And just let me be clear, is the science like the graphic with all those straight lines going out?
Yes, exactly.
Right, well, what happens now with the rest of the process? Let's look at the last bit of graphics we've got. There is equipment. It didn't work a couple of years ago. They had a burnout, didn't they?
Yes.
But this has now been shown to work.
Yes, we've been doing fantastic science at the LHC for a couple of years now. And the result today was the first tantalizing evidence towards the Higgs boson being a reality. It's not a discovery just yet. There's another year's worth of work to do.
Tantalizingly close, they said.
Yes, I mean, it's the first evidence. So far, all we've been able to say is that we haven't found it in certain mass ranges. Now, the two different experiments that go on at the LHC have said we found something that's interesting at the same mass range, and they've not been talking to one another until today.
And Martin, finally, the Big Bang. Why does this matter to all of us? You're a scientist, you're worked up about this, but why does this matter?
Well, the early universe is supposed to be extremely simple. The most fundamental laws of the universe were present at the Big Bang, and our understanding of it is that it's built around symmetries and really elegant mathematics. And the Higgs boson is a key part of that, and it's the missing part of the jigsaw puzzle that we've been missing for about 50 years.
Are you excited?
Well, I'm quite excited, but I'll be even more excited in a year's time.